To the video. Today we are going to solve insertion sort for singly linked list. In the question we are given a linked list of length n and we have to return the sorted version of this given linked list in ascending order. But the catch is we have to use insertion sort. So if you do not know insertion sort, I'll tell you simply. It is similar to that we do in bubble sort, but here we will compare with the next element. Okay, so I mean it is not similar to bubble sort is much more time complexity, and insertion sort only goes for n square, order of n square. So as you can see in the example one, this was unsorted linked list and we return the sorted one. In example 2 also it is of length 7 and we return it in the sorted manner. Given time complexity is n square and the constraint is that n value can be much larger. Okay, so if it not let's say insertion sort, I would have done in much simpler way, but since it is asked to do us insertion sort, we will do that so that we learn also. So first of all, I'll create a dummy node, and dummy node I will pass zero value. The first node will have value 0. Okay, we'll just remove it at the end. So first of all, and see, we are given head in the input. Okay, now I've created a dummy node with value 0 with data 0, and I'm storing next this head in the next of this dummy node so that the linked list starts after this element, so that we know that we are starting in the right direction, because we have to return in ascending order, and that is why I'm starting with 0, so that the first node will always be 0. Okay, now I create two variable, previous and current. So previous will store the head and current will store the next of it. I mean the next value of the current value. Just name current, but it will hold the next value. Dot next. Cool. Now I will traverse while there is a possibility that there will always be a next element from current position, which means we will go through the n minus 1 term, because as I said earlier, we will comparing current element with the next element. So I will only go till n minus 1 element. So that I will compare n minus 1 element to the nth element. Cool. Now I will just check if current dot data greater than equal to previous dot data. If that is the case, then swap them. Previous will become current and current will become current dot next, and then continue. Keep on doing as it is. Then I will create a temporary variable to hold the dummy value. Okay, this temporary will hold dummy. Now while this current dot data, which means the next element data is greater than temp dot next dot data. Temp dot next is what? Dummy dot next. Dummy dot next is what? The first element. Okay, so we are taking the edge condition over here. So temp is equals to temp dot next. It should be greater. It should be greater. If it is greater, then keep on traversing the next, which means we are moving ahead in our given linked list. Okay. Now again, lot of swappings. So current the, the previous dot next, which means the current value, the next value will become the what? The already next value. Okay, current dot next. And now this current dot next will store this temp dot next. What is temp? Already we have seen that they have traversed forward in the our linked list, so that there's always the previous element is always smaller than the current element. Okay, and then again this temporary variable will store current, current will store previous dot next. Okay, now just that after this we have seen the current value, the current dot next value got updated to the previous dot next. Then this current dot next, since it was empty, so it stored the next of temporary value, and this temporary stored the current, and current stored next of the previous value. So let me just correct it. and let me return it. So that, and as I said earlier, the dummy was for just our edge case control. That is why I'm returning next value of dummy and not the not from dummy itself. And it should do the job. Yeah, example test case is running. So I'll test for the entire test cases. Okay, let's hope. Yeah, it does the job. It does the job. It is a compiler, it is taking time. That is why it is doing fine. Okay, see, it takes time because it's order of n square and n can be very big. But at the end, we are able to solve it correctly. So I hope you enjoyed this insertion sort of linked list. Thank you. Have a nice day.